The law of sines. When we used SOHCAHTOA to solve triangles, we were solving right triangles. But of course, not all triangles are right triangles, so we need methods to solve those as well. And so one of the methods is called the law of sines. So we're going to use this model somewhat for this section, but keep in mind that the triangles won't be to scale. Angles are labeled with capital letters and sides with lowercase. Side A is always opposite angle A, side B is always opposite angle B, side C is always opposite angle C. So the law of sines is this ratio of three fractions. The sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. And we'll only be using two of the fractions at a time when we're working these problems. Also, your calculator needs to be in degree mode for this lesson. Solve the triangle using the law of sines. Remember that solve the triangle means find all the missing sides and all the missing angles. We can easily find our missing angle B because we know all of the angles inside a triangle add to be 180. We can subtract the two that we've been given, so angle B would be 180 minus 118.3 minus 12.2, and we end up with angle B 49.5 degrees. So 49.5 degrees for angle B. Now we need to pick out two of the three fractions from the formula for the law of sines. The only fraction we have all the information for is sine B over B. We've got both the angle and the sides for B. So that's the one we use. It's the one we have all the information for. It doesn't matter then of A or C, which one we choose. I'm going to use the A's. So I have the B's, and I'm going to use the A's. Law of sines would say sine and angle B is 49.5 over side B, which is 17.3, equals, and then the A's, sine of angle A, 118.3, over side A, which is what we don't know. So you should always just be missing one letter. Then to solve this, you cross multiply, and we have A sine 49.5 equals 17.3 sine 118.3. Divide both sides by sine of 49.5. Then all of that goes in your calculator at once. When you push sine, it gives you a parentheses that you'll need to close. All of that in the calculator, rounded to two places, we end up with side A is 20.03. Now we have two of the three sides. Sometimes students are tempted to use Pythagorean theorem to get the third side, but we can't do this because it's not a right triangle. So we have to use two fractions from the law of sines again. I always go back to the first fraction used, which was sine B over B, because I know that most of that has to be correct. I probably didn't mess up subtracting from 180, and side B was given to me, so I feel more confident about the information with the B's. Setting up the B's then, again, we have sine of 49.5 over 17.3, and now I'll have to set that up against the C's. Sine of 12.2 over side C, which we don't know. Cross multiply. C, let me draw a line down here so I can separate the work. C sine 49.5 equals 17.3 sine 12.2. Divide both sides by sine of 49.5. All into the calculator. Whoops. And we end up with side C, rounded to two places, is 4.81. Now we have found all three sides, all three angles, so the triangle is solved. Let's try one more. This time we only have one angle, angle C, and we have side C. So we have no choice but to use the C's to start off with. Sine of angle C, which is 68, over side C, which is 15. Now, A's and B's, we don't have anything for the A's, so we'll have to use the B's. Sine of angle B, which we don't know, over side B, which is 12. Cross multiply, 12 sine 68 equals 15 sine B. Then go ahead and divide both sides by 15. 12 sine 68 over 15 equals sine B. Now, if you remember the little quick lesson about inverses, if I want to get an angle by itself and I need to get rid of sine, I do inverse sine on both sides. So all of that fraction would be in parentheses, and then the little 68 would be in parentheses, so be careful about all of that. And angle B then is 47.9 degrees. Now we can solve for angle A. We can subtract from 180 the two angles that we have. 180 minus 47.9 minus 68 gives us 64.1 degrees for angle A. All we're missing now is side A. So let's use the C's again. We know they're right. Sine of 68 over 15, and now set that up against the A's. Sine of 64.1 over side A. Cross multiply. A sine 68 equals 15 sine 64.1, and divide. And we end up with that side A is 14.6. The type of triangle that the law of sines solves is one that we've been given two angles and a side, which would be angle, angle, side, or angle, side, angle. The law of cosines, which will be our next lesson, is used for side, angle, side, and side, side, side. There's a problem when we have side, side, angle. This is called the ambiguous case. It's possible that the measurements cause the triangle to have one, two, or no solutions, but we will not be dealing with this special situation in this course.